We have observed on multiple occasions that half-cut apples, brinjals, or potatoes turn brown quite rapidly. This is because these plants contain phenolic chemicals that can be oxidized by a class of enzymes called as phenolases. The basic function of phenolic chemicals in plants is protection. When you expose these compounds to oxygen, phenols are converted to diphenols and subsequently to quinones. The quinones produced undergo a series of polymerization reactions to yield melanin, which contribute to the brown color formation in cut apple, brinjals, or potatoes. Does the word melanin ring a bell? It is the same pigment responsible for skin color in humans. Since an enzyme is responsible for conversion, the reaction is called as enzymatic browning. The enzymes involved include phenolase, polyphenol oxidase, catechol oxidase, or any other oxidase that is capable of breaking down your phenolic compounds. Now, this enzymatic reaction can be desirable in several foods like cocoa, tea, dates, but undesirable in fresh fruits and vegetables. Fresh seafood is also susceptible to enzymatic browning. So, how can we control enzymatic browning? First and foremost, ensure safe transport of fruits and vegetables from farm to fork. So, if during transport we have some sort of mechanical damage that is caused to our fresh fruits and vegetables, it can promote enzyme activity resulting in melanin production. Suppose, let's say, our apple undergoes some sort of mechanical damage during transport. When we cut open that part of apple, we can see that it is brown in color due to enzymatic browning. And you don't want to sell such an apple to your consumers because there's no economic value. Nobody will be willing to buy that apple or pay for it. Second one is the removal of oxygen using MAP, modified atmospheric techniques. So the reaction can only proceed in presence of oxygen. If we remove oxygen from our packages, the probability of enzymatic browning is reduced. Third one is use of acid. Enzymes generally tend to work at an optimum pH and temperature range. So if we make use of acid like acetic acid, citric acid, we tend to reduce the pH of the media, meaning it does not facilitate enzymatic activity. So when you increase the temperature, the principle is the same. Enzymes cannot act at varying pH or temperature because you need a particular optimum range for their activity to occur. Fourth one is use of antioxidants. Antioxidants, they reduce the browning effects by their ability to interact with oxygen. Finally, you have certain chelating agents. So polyphenol oxidase, it has a prosthetic group which is copper, made up of copper ions. When we add chelating agent, it can suppress the activity of enzyme because they tend to bind with copper ions. Thank you for staying with me through the video. In case you have any queries, please feel free to put them in the comment section and I'll get back at the earliest.